Hello everyone, my name is Dong Shiliang from the Iwate University. It's my pleasure to introduce my research. My research title is Effect of the Superchilling Storage on Maintenance of the Quality and Freshness of the Pacific Oyster. The Pacific oyster is one kind of the important economic species as seafood in Japan. The production of oyster in Japan was 177 kilotons in 2018. Nowadays, with the improvement of the living standard, more and more people choose to consume fresh oyster for raw, like sashimi in Japan. The shelled and shucked oysters are two main ways of selling to consumers, and the refrigerant conditions from the 0 to 10 degree. However, as the fresh seafood, oysters have a short shelf life, only 4 to 5 days. Improvement in the shelf life can have an important economic impact by reducing losses. Therefore, we need to find one way to enhance the freshness and quality of the oyster for raw. Oysters have been reported to survive for as long as 20 weeks out of water, although immersed oysters may survive and can be transported for a long time. Their appearance, smell, and content of the spoilage bacteria change significantly during a few weeks of storage. This is the food safety stand of the microbial for raw oyster in Japan. Superchilling is one method used to extend the shelf life of products without reducing the quality. At superchilling temperatures, microbial activity is reduced and most bacteria are unable to grow. Based on the previous experiments in our lab, the frozen point is around -2 degrees, so we choose -1 degree as the storing temperature. The purpose of this study is to investigate the effect of the -1 degree storage on maintenance of the quality and freshness of oyster. This is my experiment design. The fresh oysters were harvested from the mine. All oysters were placing them in the filtered seawater, sterilized by the ultraviolet rays for 24 hours to reach the raw level. The oysters were divided into two groups. One is shelled and for the SL groups, and the other one was shucked was the SK group before the storage, and then all samples were stored at -1 degree for 0 to 5 weeks. We analyzed several indicators, including pH value, ATP and its related compounds, AEC and K prime values, and also free amino acids, microbiological test, and sensory evaluation. This is the result of the sensory. The SL group was still alive and fresh after 21 days. Here is the video to show the hard moving of the oyster. So until 28 days, most oysters were died and with the bad smell. To 35 days, all the oysters were died with the strong odor, and the SK group were regarded as the acceptable until 7 days to 40 days. The oysters started to occur a little bad smell. The appearance of the oysters were kept in a good condition. The gill of the SK groups in 28 days is unclear to see. This is a result of the microbiological test. From the table we can see, even after 35 days, the microbial and bacteria of the SL group was still kept in the low level, and SK group were also in a low level until 14 days. Besides on that, we can see the microbial and bacterial growth were inhibited effectively at -1 degree. This is the pH value on the adduct muscle of oyster. The initial pH was about 6.98. The SK group was decreased faster than the SL group. At the end of the shelf life, 21 days for SL group and 7 days for the SK groups, the pH of the SL group was 6.52 and the SK group was about 6.49. From this, we can see when the pH in adductor muscle is larger than 6.5. The oysters could be regarded as acceptable for raw. This is a result of the ATP-related compounds in 4 parts of the oyster: its adduct muscle, gill, mental, and body tract. From the fork, we can see the total content of ATP-related compounds were decreased during the storage. For the SL group, in the adductor muscle, ATP, ADP was decreased and AMP was increased before 14 days and then go down. In other 3 tissues, the content of the ATP and ADP were kept in high level than other compounds, and the ATP was relatively remained stable before 21 days. ADP increased at first and then decreased. Differently, ADP in gill and mental began to decrease in day 14, but in body tract was day 7. Only a little content of the HXR and HX can be detected in all tissues. For the SK group, the total content of the ATP-related compounds will also decreased during the storage. In adduct muscle, IMP was increased in first 4 days and then decreased. ATP, ADP, and AMP were decreased during the storage. After 7 days, the level of HXR and HX were increased with time. In other 3 tissues, the content of ATP and ADP were also relatively kept in high level than other compounds before 7 days. ADP was increased in first 7 days and then go down. This shows the AEC, K, and Kprom values of 2 groups. For SL group, in the adductor muscle, AEC value increased slightly from the 44% to 48% on first 2 days, and then decreased to the 50% during 28 days. K or Kprom value were kept in a very low level until 28 days. In last 7 days, increased from the 0 to 40%. In other 3 tissues, AEC value will remain at around 60% until 21 days. K or Kprom value were kept in a very low level. For SK groups in the adductor muscle, K value increased slowly from 0 to 10% at first 7 days and then increased repeatedly. Kprom values increased faster from the 0 to 24% than K value. Both K and Kprom value increased linearly with the time go on. In the gill and mental, AEC values decreased generally during the storage. K or Kprom value were kept in a very low level, except in gill at the last 7 days. This is a result of the free amino acids. The result showed the total content of the free amino acids was decreased a little after 28 days, but there was no significant difference among all groups. Taurine is the mean content of the free amino acids, and the content of the glutamate, glycine, and alanine was larger than other compounds. Last is the conclusion. The superchilling storage at -1 degree was confirmed to maintain the freshness of the Pacific oyster for the raw precipitation, it can prolong the shelf life of the shelled oyster 21 days and also can keep the oyster alive. For the shucked oyster, can extend it 7 days. The microbial growth of the oyster can be effectively inhibited at -1 degree storage when the pH value in adduct muscle of oyster is bigger than 6.5. The oyster was still fresh. In this study, the adduct muscle was the best part to analyze as the freshness indicated. The AEC value of the shelled oyster and K value or K prime value of the shucked oyster could be used as the freshness indicators. So thank you for watching.